I hope my audio is carrying. Everybody can hear me. All good to start. Firstly, very good evening to all of you guys. Hope you're all keeping safe and well today. Today we are going to continue. Yesterday, the last session we did was a conceptual session where we understood a lot about the entire page system, how data is stored on pages, how those pages are organized. We spoke about pages that track information, space allocation, and pages that actually store your data and indexes. We spoke about pages like the PFS, we spoke about GAM, we spoke about SGAM, and we understood how those actually work in the entire system. I'm going to start today with an hands-on demo. As I said, that session was a session which was required for us to go into actual query tuning. So I'm going to start with the demo today. And I'm going to open my management studio. And most of the rest of the sessions will be focused on you understanding your query and looking at how you can basically optimize that query to your best. That's taking extraordinarily longer than it normally does. Okay, and there it does. Open up. Excellent. So what I'm going to do in this particular session, we are going to basically do a demonstration. I'm going to clean up that database which I have there, and I'm going to create a new database. And I'm going to call this database FG demo1. That's file group demo1. And right now, the simple thing which I'm going to do is I'm going to have this particular file group called demo1. I'm going to rename this file name to meta data. Since we all know why we are doing this right now, because the primary data file is going to be responsible for storing metadata. All the system tables are going to be there, so I'm going to call that metadata so that we understand that. We are going to have the log file, which I'm going to leave alone where it is. I'm going to create a user data file. I'm going to call this user data 1. And I'm going to be putting this on a new file group, which I'm going to call user data FG. I'm going to make this the default file group, which means if I do not specify a file group and I create any object, it will automatically go into the user data file group, which means it will go into the user data. And I'm going to put this particular file on maybe my H drive, which is currently free. So I'm going to go into H drive. No, H drive has the logs. I'm using F. Let's basically put it onto the B drive data. Okay. So I'm going to put this onto the B data. Okay. So if you're now understanding what we have right now, I'm just going to open a notepad here for you. And I'm just going to put that down so that we have a visualization of what we are trying to do here and an understanding of it. Just make that a little larger in size so that you can see that text. We've got metadata, which is one of our files. This is our file. And this is also on a group called primary. And this is stored on f/data. I've got another file, which I've called user data 1, which is my secondary data file. And this is on a file group called user data FG. And this currently, I put it on my B drive/data. Okay, I'm ignoring the log file for now. The log file writes in sequence. I know I haven't spoken too much about it, but this is not really an administrative course. But let me see if I can push that in one of the sessions, one of the days. So we've got the user data, which is here. So I click here on OK, and we've got this FG demo created. I'm going to right click on this and send you a query. I'm also going to right click on this. I'm going to go to the tasks here. I'm going to go to, I'm going to go to reports here. I'm going to go to standard reports, and I'm going to pick up one of these reports, which is actually very nice, which is the disk usage report. Wait for that to open up. And if you look at our disk space used by data files right now, you will see my user data currently has 64 KB space used. And this is the first 8 pages of the data file which we discussed. Okay, where if you understand each page is 8 KB in size, so you've got 8 pages there, that's 64 KB. That's the 64 KB of space used, which you're basically looking at there. And these are all internal pages used by Microsoft SQL Server in order to allocate and understand where space is allocated and how space is allocated. So that's the GAM, the SGAM, the PFS, the file header. These are all of those pages which we basically spoke about the other day, the last session when we spoke about the concepts. So having said that, I want to highlight to you and bring to your notice that you've got something here called the user data, which currently is on B drive, and you can see that it's using that 64 KB, which is all used by SQL Server internally. I'm going to say create table X, happens to be my favorite table name. I'm going to say column 1, which is going to be an integer. I'm going to say column 2, which is going to be a char. And for the sake of the demonstration here, I'm going to put this at char 5000. Okay. So while I create this right now, I click on this execute. What really happens, like we discussed the other day, was a series of system tables get entries. For example, you have one of the table called sys.objects, where name is equal to X has an entry which gets created for X. So this is a system table. Remember, system tables are stored on the primary data file, which means the file that got affected when you created this table was the F drive, which is the metadata file. You can see an entry created here. You can get the object ID from here. You can see this is the object ID for X. Which I'm going to put in there. You can see other information that this is a user table. You can see the creation date, the modified dates. All of this information is metadata. You will also see an entry which would have got created in the sys dot columns, where you cannot use the name anymore, so I will have to use the ID. So I'm going to basically say where object underscore ID is equal to, and I can actually place that ID there, or you can also use a function. Okay, so if you didn't want to, if you didn't really have this ID like I copied it from the last, you can actually use a function which is called object underscore ID, in which you can actually place just the table name, and this function will automatically give you the ID of the table called X. So when I execute this right now, you will see now I've got metadata for my columns. I've got my column 1 and column 2. I've got the column IDs for it. You've got the collation for the column. You've got the maximum length of the column. You can see here you've got 4 bytes for the integer data type. You've got 5000 for the fixed data type char. So this is the system information which you basically see. Another important table that we're going to be using throughout the system is this table called sys.sysindexes, where object ID, let me just copy paste that instead of typing it. We're going to basically say where ID is equal to, so I go in here, I say where ID is equal to object underscore IDX. So I'm picking up another table called sysindexes, which is going to have information about this table called X. And here you will see some very interesting components and configuration, which is very important. You'll see first here is got a value called 0x000. I'm going to put that in a comment here so that you can see it. You will see another column which is basically got root, or which also has a 0x000 as at this stage. Okay, and these are all like, when you see a 0x, it actually means it's an hexadecimal value, and when you see all zeros there, this actually is the default value, which means there is no value at all as of now in that. Another important field in this table is the one called first IAM, which also has a 0x000. Another important column here is basically D pages. And let me highlight that to you right now. You can see D pages basically has 0 in it. So the D pages, which means data pages, is 0. You have another column called used, which I'm going to highlight to you here. You can see the column called used. This also basically has 0 pages currently. We also have a column called rows, which will tell you the number of rows which are there in this particular table. And currently you will see that the rows are equal to 0. You can see this last one right here on the right on the screen. Okay, the rows in this table is currently equal to 0. Another interesting value which you can basically highlight and look at all the time is something called an ind ID, a very important value which I'll explain to you as we go through this demo as to what this represents. But the ind ID here also has a value called 0. Okay, so those are quite a few important columns. What I'm going to do at this stage is I'm going to, instead of saying select star there, I'm going to say ID, column, ind ID, column, first column, root, column, comma, sorry. And I'm going to also pick up the first IAM, comma. I'm going to basically pick up the D pages, comma. I'm going to pick up the used, comma, and I'm also going to pick up the rows. So these are the important ones which you want to focus on right now. So instead of giving you a whole list of those columns by doing a select star, I'm going to basically pick up only a list of these columns which are here. Maybe I can pick up another one also here called stat blob, although you're going to see that always at null. But let me just pick that up because at some stage I will have to be explaining that to you. So I'll also put in the column called stat blob. Okay. So if you're looking at this here right now, I say select ID, ind ID, I basically execute this. These are now only focusing on these columns, which are important to us and which we are looking at. Currently, you've seen the values in these columns, and you can see these values now are first, root, first time, D pages, used, rows, ind ID. You can see the values which were there in them. And this is for a complete new table that I just now created. Now, while I created this table, okay, only thing that happened was metadata got inserted. Now, when I look at the disk usage here and I refresh it, you will notice that my user data 1 still remains at 64 KB. You can see that right here. It still remains at 64 KB. You notice this guy is not even basically changing in terms of basically what we want to see and so on. You'll see that that guy is basically still at the default value. It's still at 64 KB. Why is it? Because when we created this table called X, while this table got created on the group called user data, okay, so if I type sp underscore help X and I look at the metadata which this is going to throw out, you will notice the table called X is owned by DBO, okay, and you can see it was created, it's a user table. On which file group was this created? If you look at the bottom here, you can see this table was created on the default file group, which was user data FG. And the user data FG, why? Because it was the default file group. And the user data FG file group has the user data 1. And in spite of this table being created on the user data FG, currently you notice it has not used any space for the table creation. The reason being is the table creation only created metadata, and the metadata went into the metadata file, which was on F drive, which you can see in the first row right here. So this was the file that really got affected when you created it. This also means to us that when you create tables in SQL Server, it does not really use space. It only basically, it uses some space, but it uses it from the primary data file. Because what it does there is basically creates the metadata and all these system tables that we just now queried, but it does not really conserve any space for the system. Now I'm going to basically do an insert into this table called X. And I'm going to put in some dummy values here. I'm going to put in the value 1, comma, let's put in something called, okay, I'm going to just call this ABC, not being very creative today. And now please understand now that this ABC which we are putting in, The column data type for this is basically a char 5000, which means even if you entered one character, the space that will get taken will be 5000 characters. And for column 1, which is an integer, 4 bytes will be taken, and then you do have a row overhead which will also basically be taken, and so somewhere around 5011 bytes is what this guy will consume in all. I'm going to go ahead and make that insert, and one row now basically is affected and one row is inserted. I go back to my sysindexes and I click on the execute here to see how have things changed here. And you will notice almost everything that you see is different except a few. You will notice the ind ID is the same. That's not changed. Your ind ID was 0 earlier. It still remains 0. At this moment, the first and the root are not too relevant, so I'm going to ignore them until they become relevant. But at this stage, the first IAM is very, very relevant. You will look at the first IAM now. Here basically has changed its value to something else. Now this is a reverse bit-to-bit algorithm which you're basically looking at. I will basically in our next session show you how you break that up and how you can basically decrypt that so that you understand what is this actually representing right now. It's a hexadecimal value, of course, and the hexadecimal value represents for you here the file ID and the page on which and a page number. So it represents the file ID and a page number. So you will come to know which is the file and which was the page on that file, which will take you directly to this particular page. So you'll know the page address, you'll know the file at which this page is located. So in simple, this is the address of a particular page. I will show you how to decrypt it so that you can actually pick up the page number and file number from there. But right now, just basically go with the blind trust here that this is an address of a particular page. Now this earlier did not exist. The minute you put in the first row here, this guy basically changed. He now got an address of the first IAM. The other interesting thing that you'll notice is the D pages now has basically changed from 0 to 1, which means we have one data page here, which is logical. I had to store the data somewhere. So I needed a data page. So the system allocated a data page. Now, I hope you remember the last session in which we spoke about how this allocation takes place. We spoke about SGAM, how the system finds an extent which has a free page, marks that page as allocated, and then uses that page in order to basically store your data. So that's exactly what happened right now. He found a data page, he inserted, marked it as allocated to the table X, and he picked up the address of that page and he stored it on an IAM page. Another interesting change that you will see is the used pages now is basically equal to 2 and not 1. I inserted one row, so one data page was required, and yet this table is using 2 pages. Now, if you go back to understanding the story from the concept which I shown you last time, when I created this table, nothing happened in terms of allocation. Only metadata got inserted. When I tried to insert the first row, the system noticed that the address in the first IAM was a dummy value. It was 0x00000, meaning an interpretation that means that this particular table had no data page. So no first IAM page, no IAM page. That more or less this is happens when the table is new or when you truncated a table. In fact, I use the word truncate right now, but I'm not going to divert here. I will come back to how truncate works. But currently you can see that he understood when he tried to insert this record that the first IAM entry was a 0x000000 all the way, which means this particular table called X does not have an index allocation map. So he forgets about inserting a row. He says, first I need to give this table an index allocation map. So he goes into the same path of SGAM, goes to the shared global allocation map, finds an extent which has a free page, picks up that free page, marks that page as allocated as an IAM page, picks the address of that page, and puts it into this column called first IAM. Now you notice this particular address is pointing to the index allocation map of this particular table called X. So the minute this index allocation map got aligned, one page got allocated. After this page got allocated, he still had the job pending. He still hasn't basically inserted your values 1 ABC. Now the next thing which he needed was a data page. Again, he went back to his GAM. He basically found a page, a mixed extent that had a free page, marked the page as allocated, picked up this data 1 ABC, put it onto that page, took the address of that page and put it onto the IAM page. Now you will notice one data page also got allocated. So one data page that stores your value, that stores your data. And here you can see one IAM page that was allocated that stores the addresses of the data page. Stores the addresses of the. So this is as simple as that right now, right? It seems so straightforward and so amazing of how the system works. So right now you've got one index allocation map. Now how does he find the index allocation map? You've got the address stored right here in the sysindexes table, so he knows where it is. He knows what this is about. So when I do a select star from X right now, what does the system do? I'm going to say select star from X. I'm going to go to the query here. I'm going to say include actual execution plan. So I can show you that execution plan. I'm going to click here on execute. And you can see here he throws me one ABC. But when I look at the execution plan, you can see that he's doing a table scan. Now, what is the meaning of table scan? Now, the meaning of table scan is this guy went to the sysindexes table. He found the address of the IAM page, which is this one. He went to that page, and on that page, he found the address of only one data page that we currently have. So he went to that data page, he read your row from that data page, and he gave you the results. One ABC, right? This is called a table scan. I'm going to also do something else for you right now. I'm going to say set statistics. Oh, I always struggle with that spelling. Set statistics, IO on. I'm going to execute this for you, and I'm going to re-execute now the select star from X for you. You get the same results, of course, no difference. The execution plan is still says table scan. And now when I click on the messages here, he will tell you your logical reads were 1, which means you had to hit one page in order to basically get these results. Now, impressive. So this is what we call your IOPS. So when we talk about input-output operation, when we talk about optimizing queries, we are talking about keeping these reads at the lowest. Every number that you see here talks about the number of pages you had to access, you had to hit in order to get your results. Now this, I've kept it very simple as of now, but what will I do now is I'm going to insert another record right now to ABC. Just before I do that, let me show you something else. If I come back to this particular page and see what has happened to the 64 KB, you can notice here this guy has actually jumped to 192 KB from the 64 KB that was originally allocated. Now this jump has happened majorly because he needed more space. He could not use that 64 KB. And what is the allocation unit on your disk is something which you configure when you're basically mounting your disk. You basically will configure whether it's supposed to allocate 128 KB or 64 KB at a time. So this is more related to your operating system and your how space is allocated from your disk. Okay, so in this case, you will notice this guy straight away allocated 128 KB because we were originally at 64 KB. So he basically allocated 128 KB more, okay, which is not yet used because I'm using only 16 KB. I'm using one IAM page and one data page, 8 KB each, which means my total usage at this moment is only 16 KB, 2 pages. But this guy at the operating system level, at the file system level, gave me an allocation of 2 extents, that's around 16 pages, although the usage is currently only 2 pages. No worries with that because at the moment it doesn't mean you're using it. Okay, it means the operating system simply basically said, great, I'm going to allocate this. This is now going to be treated as used. I'm going to mark this as basically given to SQL Server. So that's all your operating system did. You basically mark that as use space by your system, but you're not really using it right now. You can use it in the future, but currently you're not using it. We are currently using only 2 pages, and I've shown you how those 2 pages are. One, we are using the IAM page, and one data page. Now, if I basically try to insert a second record here, now please notice now, I've already explained this in a previous session. Based on the row size that I have right now, one row can fit on a page. The second row will go to a new page because the total row size right now for me is 5008 bytes. Okay, the page size is 8060 bytes. Although I have a 3002 bytes here left, 3052 bytes here left, it cannot be used. This space cannot be used. Reason being is the next row which we create will also basically be a 5008 bytes row. There's only 3052 bytes left on the page. So it cannot be used because it needs 5008 bytes. So automatically the next row will go into the next page, because like I explained in an earlier session, SQL Server cannot split a row across pages. The row has to entirely fit on this page, or it has to go to the next page. You cannot put half on this page, half on the other page. For this example, because we are trying to demonstrate space usage and allocation, it was a good idea to make one row, one page, and that's why I put in those sizes. That was a deliberate thing which was done. So if I insert a second row now, you should understand that this basically will automatically create a second page. If I check my sys indexes entry right now, you will notice the D pages went up to 2. Use pages are still 3. Why? Because he does not create a new IAM page for every row or every page. An IAM page is created, it has 8060 bytes on it, it can store multiple addresses. So currently the IAM pages is storing the address of 2 data pages. So the total use pages is 2 data pages for the 2 rows of data that we inserted, 1 IAM page which is equal to 3 rows of, which is equal to 3 pages. So 2 plus 1 is 3. And now, if I go back to execute my select star from X, you get 2 rows. You look at the execution plan, it's still a table scan. And if you look at the messages now about input-output operation, you will see your logical reads are 2, because you had to hit 2 data pages in order to give you your results. I will go back again here. I will make this 3, and I'll make this also 3. Sorry, some values. I will insert that. So now we've got 3 rows inserted. Your sys indexes now, because every row now represents 1 page for us, very easy calculation. You got 3 data pages, 4 use pages, so the IAM page is still now if you're visualizing, you're creating a picture of this, you will realize that your IAM page now has the address of 3 data pages on it. And now if you look at your select star from X, it's still an execution plan. You get 3 rows, and in the messages now you will notice your logical reads are 3. Okay, so I think this is pretty self-explanatory, and you're understanding the way the flow is going. If I go back to the disk usage right now and I check to see whether anything has increased here, it will not increase logically because I have enough pages already. I'm still at 192. I'm using totally 4 pages right now out of the total 16 pages that was allocated to me by the operating system. So I'm pretty safe. I don't need to expand this file anymore. So this still stays at 192 KB as far as data 1 is concerned. I'm going to now basically very quickly insert some duplicate rows here. So I'm just going to ask you for around 30 seconds to do that. So I'm inserting row number 4, then I'm inserting row number 5. Then I'm inserting row number 6. I could have created a loop to do that, just a little lazy right now. So I'm just going to go ahead. Plus it's always good to help you visualize by giving you that time instead of just basically executing a script to quickly create 10 rows. Okay, now at this stage, when it's 7, okay, I've got 7 data pages, 1 IAM page. So the total pages used will be equal to 8, which means I'm using up a full extent. You can see the total used pages are 8, and the data pages right now is equal to 7. And if I check my select star from X right now, just like you always seen, the execution plan is still a table scan. And as far as the messages are concerned, I picked up 7 rows. I had to go to 7 different data pages to pick up those rows. And this is where you basically see your logical reads are equal to 7. So looks good. Okay. And if I go to my disk usage here and refresh this, and I drill this down, you will notice this guy is still comfortable. He says, buddy, you got enough pages, you got enough data. I don't have to expand this file. I'll leave this at 192. You're using 8 pages, but I'd given you 16 pages. Okay. Please remember this 192, 64 KB used by the system internally. You cannot touch it. 128 KB given to you, out of which currently you're using basically 64 KB. That's 8 pages. Another 64 KB still available for your usage. I'm going to go back here and basically now expand this once more to 8. 9. And 10. Now at this stage, okay, I'm using 11 data pages, right? So if I look at my sys indexes, there are 10 data pages and total pages used are 11, 1 IAM page. If you're imagining the IAM page right now, you can imagine it with 10 addresses. Think of it as a sheet of paper with 10 page addresses on it. So from the IAM page, I know which are the 10 data pages that belong to the table X. And that's exactly how I go and scan them. And that's exactly what my system, whenever you see this icon called a table scan, you need to imagine and understand what the system is doing is going to the IAM page. How does he know where the IAM page is? It is stored in the sys indexes in the column called first IAM. So he picks up the address from here. He finds the IAM page. On the IAM page, he finds the address of 10 data pages. He goes to all of the 10 and picks up all the data which is there from there and gives you your 10 rows of data which you're looking at here. You see your execution plan is still a table scan. You see your messages now says you read 10 data pages in order to get this result. I'm going to go back to the disk usage here. I'm going to refresh this. And you will notice here, at some stage, the system said, buddy, you continuously are using pages of mine. I need to allocate you more space. And you notice this guy jumped again. Okay, he jumped by another 64 KB. So this is more basically the system trying to allocate in advance, so that does not have to do it at the nick in time. So it's not just in time allocation. So you can notice here this guy is basically allocating ahead in advance. I've still not yet used the whole 16 pages. I'm using only 11 pages, and yet he allocated another 64 KB. But again, guys, please don't get confused with this. This is more at your operating system level, at the file level. It has nothing to do with SQL Server's usage. SQL Server usage is still basically just 11 pages for you. It's only basically using 10 data pages, one IAM page, total pages of 11. Now, at this stage, I want to basically point out to you, I've been running the same query on the sysindexes table time and again. And while I'm running this query here, you will notice that I'm always getting only one row. Okay, I get only one row here. And what are important to me, which I've explained to you right now, is the ind ID 0, okay, which means this particular table is stored on a heap. The terminology used is this is a table which is stored on a heap. And when I talk about a table being stored on a heap, this actually means, technically what this means is that this rows are scattered. We are having no sort order. Okay, which row is first, which row is second, we don't know. It also means technically this table has no indexes on it. Okay, so whenever you see the ind ID 0, you know that this table has no clustered index on it. This table, the rows are stored in a heap, which means there is no guaranteed sort order of the rows. Okay, that's what the ind ID 0 represents. That's what it means. First IAM, you know what this is. This is the address, 10 pages, use pages. You can see this one row, which is here. I'm going to make a small change in my query right now. I'm going to say select star from X, where call1 is equal to, let's give it some number 5. Although it doesn't matter, I could have given it any number. And the way I've inserted data into this table right now, this should give me only one row. I get only one row. Amazing. I'm going to pause here. I'm going to give you time to think. Okay. What do you think my execution plan will be? Earlier, I was scanning the entire table. I was picking up all the rows. Now I'm picking up only one row out of 10 rows. And when you look at your execution plan, you see it has not changed. The guy is doing the exact same thing that he did earlier. So when you wanted all the rows, he basically did the same thing, table scan. You want one row, he's doing the same thing. He's doing a table scan. Now, if I look at my input-output operations, now we know for certain in this particular scenario, in this particular example that we are working with, that one row is equivalent to one page. So 10 rows are on 10 pages. Now I wanted only one row. Now naturally, I think logically what you're thinking is I should be going to only one data page because I need only one row. When I wanted 10 rows, I went to 10 pages. When I want one row, it's logical. I should be going to only one page. Now, when I click on the messages here, you will be surprised that the logical reads still say 10. Which means to pick this one row, I went to 10 pages. Now, guys, I think I've already basically put some seeds into you thinking optimization right now. Okay, if you ask me how do I optimize this, I would say, guys, the first thing is I don't want to go to 10 pages for one row. Please think about this in a bigger picture. You had a table with 1,000,000 records, and the 1,000,000 records were on 3,000 pages. You wanted one single row, and you did a select statement, and you scanned 3,000 pages for one row. Optimization. You're thinking optimization right now. So one of the first things that you need to basically look at is If this row existed on one page, why am I going to 10 pages? Why am I not going to a single page? Okay, we'll answer that question, but this is the questions that if you're really thinking query optimization, these are the questions that you need to start planting in your mind. I need to touch the minimal number of pages. Okay, if this record was possible to get from 2 pages, I need to get it from 2 pages. I don't need to go to 10. If it's possible to get it from 1 page, I need to go to 1 page. That's not happening in this case, and we'll learn across these sessions how to make that happen. But as of now, another interesting learning which you look at is, which I cannot avoid at this time, but to show you is, when I make the select star from this table right now, my sys indexes, earlier I got only one row and suddenly you will see a second row appear. All null, null, null values here, none of them relevant, but you will see the int ID now is equal to 2. Why did this row get created in the metadata? What is this row about? When did it get created? Okay, I didn't do anything. All I did was basically made a select statement. I didn't even say an insert. I didn't even say create. I just said select. And another row got inserted in the metadata. Now what happened in this case is, earlier I was saying select without a where condition. Now I use select with a where condition. I put in column 1 here. When I put in this column 1 in the where condition, the optimizer had to basically create an execution plan. And to create an execution plan, he needed to get some information about the data inside this column 1. Unfortunately, he had no information at all about what data is there in column 1. How does he build a plan if he does not have this information? In simple, guys, if you had to reach my office and you had to travel here and you have no information about basically the roads and so on, how are you going to create a plan to reach here? You need to have some information with you to even create a plan. Okay, I heard some of you just say I've got Google Maps. Okay, so but then Google Maps, to create that map, also needed to have some information, right? So whoever has to build that map for you needs to have some information about the geography. In the same way, the optimizer here, who needs to basically find column 1, find how do I build a plan to basically pick up data where the column 1 is equal to 5. I need to have some information about the character of data, the nature of data, the volume of data, the selectivity of the data, the density of the data in this column called column 1. If I don't have that information, it's going to be very difficult for me to build a plan. So what does SQL Server do? Now you're talking performance, guys. Again, we are talking optimization, query optimization here. Now, when you executed this query and the guy understood that I don't have information about column 1 to build a plan, you know what he did? He paused the execution of your query. Paused execution of query. He said, wait, let this wait. Hold on. Okay. He said, I first need to basically collect information about column 1. So what he did, he went and sampled data from column 1. Based on the sampling that he picked up from column 1, he built information on it. This entire step, these entire step, 2 steps, let me basically put this here, step 1 and step 2. Both these steps together is called build or create. 1 and 2 steps together is called creating statistics. Yep. So what the system did was it basically created statistics. Okay. Now the problem for you and me, guys, is to understand is that this is going to be happening on your production systems too. If you have a column which does not have statistics on it, okay, you're understanding now what is statistics. The guy needs some information about the column density, about the column selectivity, okay, uh, about the kind of nature of data in that column. And this is basically called, let me go through this column, run through all the data in this column. Let me pick up samples of it. Let me, based on those samples, come up with basically the information that I want, like selectivity, density, and so on. This is the process called creating statistics. At this time, what is important for you, the query optimizer, to understand is this is going to cost you. This is going to slow down your query, because remember, he paused your query execution. He said, I'm not going to execute this query. He said, first, let me basically build the statistics. Now, that's going to take time. That's going to consume resources. That's going to consume compute. It's going to consume memory. So he paused your query execution and he basically first built statistics. After he finished the building of the statistics, he said, okay, great, buddy. Now I got enough information to build a plan. And now he goes on to basically build an execution plan for you. So all said and done, okay, this is another thing that you and I have to be thinking if you're query optimizers. How do I avoid this? Because this is something which is happening in real time. Okay, I need to avoid this. I need to basically see how do I stop this from happening at random hours. Maybe I should do this only in 3 o'clock in the morning when nobody is basically awake. Okay, hopefully. Okay, or I need to do this at non-peak hours. I cannot afford statistics to be built, and statistics takes time. If it's the larger table it is, the more amount of time it takes to sample and then basically pick up the information that it requires in order to store statistics. So that's what happened in this case. When I put in that value here, okay, he had to do this stuff. So after doing this stuff, he basically has the information. After having that information, the guy still basically decides to use a table scan and still decides to go to five. Sorry, that's not the right query. This is the query which I need to look at the execution plan for. He still does a table scan. He still basically goes to 10 pages in order to get it. Now look at the performance of this query. I know right now that basically executed in a microsecond, okay, because it's a small query, small table, but I want you to think about this in a bigger picture. Okay, the table was large. You basically don't have any indexes on that table. You are scanning multiple pages. You want one row, but you're scanning all the pages in the table. Okay, you also pause the query execution. You first build statistics and then you executed the query. Okay, so all of this is going to basically result in your slow query performance. Okay, so let me go back here and show you this, and just to basically show you, give you proof of concept here, let me basically show you. I'm going to say sp underscore help stats, and I'm going to put in the table name X, and I'm going to execute here. And this guy tells me, you see, statistics was built on column 1, and this is the name of the statistics. Now, that's some weird name the system automatically created for it, but you can see statistics got created. Okay, so this is proof of concept. Stats got created. Okay, I can basically go ahead and say drop statistics, table name dot statistics name, and I can execute this command. And now when I say sp underscore help stats, you'll see no more stats. Okay, no stats at all. Okay, the system says this table has no stats. Great. Now, if I do a select star from X, I look at the execution plan, table scan, 10 results, messages, all good. I say sp underscore help stats. Still no stats. System says no stats. I execute here. Still one row, no two rows. If there were stats, another row would have got created. But if I basically simply change this query to select star from X where column 1 is equal to 5 and I execute it, now you will see the change happening. So I've just given you proof of concept. Statistics got created again because the system you used a column in a where condition. So when does statistics auto get created? If a column has no statistics on it. I repeat, if a column has no statistics on it. If a column has no statistics on it. And the column is used in a where condition or a join condition, the system will first build stats for the column and then build the plan and then build the execution plan. Now this doesn't take every time. Now see, once I've basically created statistics on this column, the next time when I execute this query, the guy will use the statistics. He won't create it again. This is only for the first time when you execute a query. A column is basically a part of a where condition or a join condition, and this query and this column has no statistics. The system will create statistics. But if I execute the same query again, the system is not going to go all over creating statistics again. Now, this column falls into the condition where it has statistics. So we'll use the existing statistics and build the execution plan. However, statistics will get outdated. Stats will get outdated. Now, when do stats get outdated? Whenever 500 plus 20% modifications happen on the column. So it created statistics today. You had 10 records in the table when he created statistics. Amazing. Now you will continue using those statistics until your table reaches 502 rows. 502 modifications has to happen on column one. Now guys, the modification may not necessarily be inserts. It could be updates, it could be deletes. So modification is an insert, update, or a delete. So any of these, when the number of insert, update, deletes on this column, not the table, on this column, reaches 500%, 500 plus 20% of the existing rows. Now the existing rows was 10. So 20% of the existing rows, sorry, forgive my maths, it was bad. That's 4. 20%, oh, sorry, I was right. 20% of 10 is 2. Sorry, guys, not concentrating there. So 20% of 10 rows is 2 rows. So when plus 500 is a constant number. So 500 and 2 changes, modifications, will trigger a rebuild of statistics. Now the system, you can look at how amazing these guys are actually speaking everything basically as an explanation. There is something called a row mod counter. You see, the system here will keep track of the modifications on a particular row for that particular column. So as you do updates, inserts, and deletes, which we have not done right now, so the row mod counter is equal to 0. As you start maintaining this, the guy will say, okay, 1 delete happened on column 1, 2 deletes happened, 3 deletes happened, and he's storing it in the stats column. You see, this is the column in ID 2, which got created when you created stats. So now for column 2, this guy, let me do one more thing here in this particular one. Let me bring in the column name. What is that called? Yeah, it's called name. Sorry. So if I execute this now, you can see this is the name of the statistic. Sorry. Okay. So you can see this is you can trust me on this. This is for the column which I used column 1, which I created the where condition on. So right now there are 0 modifications. Now we'll keep a tracker here. When this reaches 502, and then again you try to basically do a select star from X where column 1 is equal to 5. The guy will see that, boss, this statistics for 502 modifications have occurred, which means this is basically outdated. So again, he will pause your query. He will rebuild the statistics on his own and then basically execute it. Okay. So guys, all said and done, I think you're understanding now problems. Okay, we have not looked at solutions right now. Okay, but the solution is simple. We need to prevent all of this stuff. How do I prevent statistics from being built automatically on the fly? How do I basically ensure that every time I run this query to pick up one row, it is not going to basically take me to 10 rows? Why should I basically go to 10 pages to read one row of data? Why don't I go to just one page? Now, these are the questions that we need to basically answer if we want to optimize the query. I don't want to build statistics. I don't want to build statistics at runtime. I don't want to access all pages for just one row. Okay, and I think this is at a very simple level, but the whole idea here is more than to basically, we will work on some larger tables as we are progressing through this series, but the idea here is to get the thinking. Okay, now you're thinking as an optimizer. You're thinking about what are these queries doing and how can I prevent it from doing this stuff? Because if I prevent it from doing this stuff, I am optimizing my query. I am basically improving the performance of my query because he's got to be doing lesser. Okay, so with that, I'm going to basically pause today's session and we're going to end this session here because I won't be able to complete the solutions in the short time that we would have in case I was trying to. So what I'm going to do, did I lose that query? I thought I'm going to save it. Oops, I think it is here. Yeah. Oh, I did lose that query. Okay, fine. So no worries. So right now I'm going to pause this here and we'll come back with the solutions as to how we can solve these problems. We've got questions which are unanswered at this stage, but we've understood problems. We've got the thinking of an optimizer. We've started thinking as to how we prevent, we've understood what the query is doing and we've understood, and we are thinking now, how do we prevent it from doing this stuff? So with that, I will open up the room for questions. If somebody has questions, please shoot, and I will be happy to answer, and we'll be able to. Uh, I'm pausing right now. I'm waiting for questions. Okay. So have a good evening, guys. Stay happy, stay safe. See you guys in tomorrow's session. Have a great evening. Rock and roll, guys. Bye bye. See you. Cheers.